Hello, this is Dan Welton, Editor-in-Chief of the Facility Market. Thanks for joining us today for today's webcast, Using Plumbing Technology for Safe and Efficient Environments. Our presenters today are Daniel Farino and Carrie Rostek. Daniel Farino is currently the Regional Director for Horizon Engineering Associates, overseeing the operation, quality, and execution of commissioning services throughout the region. Daniel has over 14 years experience providing commissioning and sustainability services throughout the United States, with a focus on healthcare and sustainability projects. Carrie Rostek is a project engineer with Horizon Engineering Associates and holds a bachelor's degree in mechanical engineering from McGill University. Her background includes designing, evaluating, and troubleshooting of a building's mechanical HVAC and plumbing systems. Today's webcast learning objectives include review how plumbing technology updates can help save water, understand how plumbing technology improves efficiencies, and learn about how to incorporate new plumbing technology into your facility. Before we get started with today's webcast, I'd like to cover a few details about today's event. A live question and answer session will follow today's presentation. To submit questions, please navigate to the Q&A button at the bottom of the screen and type in your questions. You might have to refresh or move your mouse over that area to bring back the Q&A area. Our presenters will answer as many questions as time permits. At the conclusion of today's webcast, you will receive a PDF copy of today's presentation slides. You'll also receive a link to a brief online assessment, and upon successful completion of this assessment, you will receive your CEU certificate. And with that, I'll turn it over to you, Daniel.
Okay, great. Thank you so much for that great introduction, and thanks everyone for joining today. So, why are plumbing upgrades so important? So, as we talk about plumbing upgrades, this really focuses on a lot of our fixtures, our bathrooms, our kitchens. So, let's talk about them. So, water conservation is a really important topic throughout the world, and this limited resource is only becoming more of a global concern each and every year. We're seeing more and more droughts, more and more shortages and more limitations put into place annually. Across our country, many localities face consumption limitations regarding water usage in their everyday operations. While many of these regional limitations focus on irrigation systems, the water utilized in commercial buildings should always be considered, as it accounts for about 17% of the municipal water demand in the USA. Studies have shown that this water consumption averages approximately 20 to 30 gallons per square foot across most building types, maxing out with inpatient healthcare facilities at about 50 gallons per square foot, and with the cost of water and wastewater services only rising, and at this point well above the consumer price index, this can solidify your case for implementing these type of water efficient measures and technologies as a function of a new or existing facilities renovation to your plumbing system. By sector, we see the largest consumers of potable water or municipal water in infrastructure, hospitality, and warehousing sectors, which take up about 50% of the total commercial and institutional water consumption, with offices, healthcare, and educational facilities taking up about another 25%. So it's probably safe to say that all your facilities out there are included on this list, as this covers, the majority of building types. Depending on your individual region, there may be available incentive programs or tax breaks, and at the same time, we can also feel good about implementing our sustainable practices as a part of a larger sustainability program within our facilities, along with the kind of feel good in protecting these valuable resources. Some of the most popular programs or incentive programs run through the EPA Energy Star and the Water Sense programs. So, implementing water efficiency at work starts with understanding a facility's water using processes. So both your domestic consumption and your process water. So developing a water management plan, which will include conducting a water facility assessment, can help us as managers and owners understand the baseline of how much water our facilities use and which of these processes and locations require the most water. An assessment also helps to identify potential water saving opportunities and calculates or assists in calculating the payback periods to help prioritize these options in our goals of reaching water savings. By understanding a facility's occupancy and water usage trends over time, they can best maximize our dollars in any future upgrades or renovations, as well as identify areas for process and domestic water metering opportunities both either permanent metering or temporary metering if you're running to a situation where you think that there may be a potential leakage that you need to assess. Additionally, there are opportunities for energy consumption savings by any reduction in the operation of domestic water makeup, pumping, and domestic hot water heating systems, along with the reduced maintenance costs incurred by updating antiquated systems that may be prone to failure, clogging, or just overall general inefficiency. So our typical areas of improvement, as we see in these plumbing upgrades, focus on the bathroom water conservation, and they focus on both flush and flow fixtures, which Kerry will elaborate on potential improvements across the board for all of these fixture types and how it impacts our overall facility water consumption. Our flush fixtures will include toilets and faucets, while flow fixtures account for shower heads and faucets. Sorry, that was toilets and urinals on the flush fixtures. We will touch on the topics of water reuse as it relates to commercial buildings and some efficient plumbing systems, such as vacuum plumbing systems, which can be incorporated when upgrading bathroom facilities. So as it relates to standard national green building standards, there are a handful of references that can be utilized depending on your jurisdictional requirements or where you're located, many of which have very similar maximum flush and flow rates across all fixtures, which are a function of kind of what the manufacturer out there and what's efficient in the overall fixture process. Some of these include Cal Green, United States Green Building Council and LEED, the ASHRAE Standard 189.1 International Green Construction Code, ASHRAE S191 Standard for the Efficient Use of Water in Building Mechanical Systems, ICC 700 National Green Building Standard for Multifamily Buildings, IAPMO Green Plumbing and Mechanical Code, and the IGCC Green Code. While the majority of these standards limit the allowable flush and flow rates for each fixture, some of them also have additional performance metrics associated with them. One of the outliers here that should be noted is that LEED and the USGBC do not require utilizing any particular fixture, but instead they focus on an overall water reduction in the building or the project compared to a baseline, so as not to dictate what fixtures can and can't be used throughout the project. Overall water savings compared to the baseline is very important for any LEED or green project, as this is a prerequisite for certification, along with additional points that may be available for exceeding those set reduction limits. It's important to understand from your design renovation team which of these standards is applicable, and if they're not applicable, what you want to follow as compared to your OPR. Again, if none of these are mandatory, identifying as they relate to your owner's project requirements, OPR, or your CFR, your current facility requirements, as it relates to your usage, your occupancy, how that's changed over the years. If you had a facility that was originally designed for 20 people and now there's a lecture hall in there and there's 100 people, you're going to want to make sure that you're right sizing your systems as it relates to your current facility requirements. So the status quo may not be enough to in your upgrades as we're looking at these systems. As we know, it's much more cost efficient to make these improvements during a planned upgrade or renovation instead of on an individual basis or doing it kind of piece by piece, as well as compared to a mandatory last minute change that has to be executed without the proper planning. So doing some, I don't want to say fault diagnostic, but getting ready and addressing these systems before you run into a failure situation will help you not have to make last minute decisions that will impact the future of your building. You want to focus on best practices in these installations. So my soapbox for commissioning of these systems, as I am a commissioning provider, although with commissioning, we typically relate this to savings with energy consuming systems, it is common practice in many institutions to expand this commissioning scope of services to include the flush and flow devices on top of typical bathroom upgrades like lighting controls and domestic hot water heaters. Your commissioning provider can help your team in performing the facility assessment and by identifying the proper specification, installation, and operation of all the aforementioned components to help reduce your overall punch list items. Some typical sampling performed with the commissioning of these bathroom fixtures can include verifying the proper operation and coordination of faucets and flow fixtures. For example, confirming the left side is hot and the right side is cold water. This happens a lot with switching the actual fixtures. Verifying properly operating flushometers, so you're getting the right pressure, the right flow, no leakage. identifying those potential leaks in your systems with a blue dye test, inspecting faucet heads for the proper installation of aerators, and even assisting with a mass MAP type load test to verify the performance of an existing or newly installed system to meet with those standards. Too often with these renovations, there may be no initial complaints, so everything is okay to go from a day one perspective. But if you have a performance-based strategy, or as you get into excessive usage with these systems, you can find errors on day two that you're left having to deal with instead of having the construction and design team deal with them. Include flushing efficiency, flow rates, and set points in your automatic systems. One quick story: we had one project where the system was designed with a green low flow 0.5 GPM aerator for all the faucets, along with a dedicated instantaneous hot water heater under the sink at each faucet. Unfortunately, it was not coordinated during the design phase that each of these instantaneous hot water heaters had a minimum flow set point of 0.5 GPM to actually engage that heating element throughout the system. So there was no way that hot water heater was ever actually going to engage to provide hot water at the sink. So luckily, we were able to identify this early enough on in the process that it never became the facility manager's issue. But I know I would be upset myself if I spent all this money on this bathroom upgrade and I couldn't even get hot or warm water out of the tap. So these are some of the benefits of looking at commissioning as we're looking at these upgrades and the improvements of technology throughout our plumbing systems.
Awesome. So I think I'm going to dive a little bit deeper into some of the components of these bathroom upgrades. I think I've gotten the control under control. So first up is the flush fixtures. So toilets fit into the categories of single flush, dual flush, and gravity tank type toilets. So the green building standards identified that all toilets shall include the maximum flow rates to comply with each system, of which many have identical standards. Not sure if these slides are progressing. There we go. So flush fixtures. Most commercial spaces stay away from the tank type toilets since they take longer to refill and require more routine maintenance. And with commercial usage estimates in commercial spaces, having water supply lines capable of providing the proper flow to accommodate the tankless type toilets. So in some jurisdictions, tank type toilets have been banned in commercial spaces due to these limitations, as they are rarely as effective as their pressure assisted counterparts. So if you have an existing tank toilet, there are retrofit kits that turn your typical toilet into a lower gallon per flush or dual flush system, but any aftermarket fix will come with its own set of problems that are probably best to be avoided. So in existing commercial facilities, it's most common to utilize the standard single flush, but not uncommon to see the dual flush type toilets in newer or renovated buildings, as they become standard in jurisdictions such as NYC to be the standard for any building installation after 2013. So the newer single flush type flushometers operate at about 1.28 gallons per flush and 1.1 gallons per flush, and will typically carry the HET naming. So that's high efficiency toilet naming. The 1.28 gallon per flush value is the standard across all the listed green building programs, along with the requirements in some instance to carry the WaterSense performance certification. So some of the issues with previous iterations of lower consumption flushometers was the inability of the system to fully clear the toilet in a single flush at the much higher flow rates, requiring multiple flushes during a single event. So that obviously negates any water conservation by utilizing a low flow fixture. So therefore, we must make sure any renovations or improvements consider both the flush fixture and the bowl fixture. On the lower end water usage of the spectrum, the units can operate at 1.1 gallons per flush. We'll typically need specialized toilet that have been maximized for this lower flush rate to ensure proper operations. So let's look at the dual flush toilets. So they are a system that's potentially a good option when utilizing existing bowl fixtures. As I mentioned, those two differences, you got to make sure that they match. And they will include a dual flush valve with varying flow rates for solids and liquids. So typically 1.6 gallons per flush for solids and 1 to 1.1 gallons per flush for liquids, as they must maintain a maximum dual flush flow rate of 1.28 gallons per flush. Lots of gallons per flush here. This will help eliminate compromising the efficiency of the bowl fixture that may have not been designed to maximize waste removal at the lower flow rate. So one of the problems with dual flush toilets can occasionally be user error, as I'm sure we're all aware, resulting in frequent clogs if attempting to flush solids with a lower flush quantity. Obviously, that's in an effort to save water, but it also results in needing multiple flushes. So this user error has been documented in various studies, finding that even though dual flush fixtures became the standard in some areas with clear instructions included on the fixture or in the area, it's not being utilized as intended. Go figure. So these fixtures, when utilized properly, can save 20% of the flush water consumption when compared to their 1.6 gallon per flush single flush alternative. So let's talk about toilet testing. We have to keep in mind this renovation approach may not meet certain jurisdictions if there is a performance-based requirement. Unfortunately, not all toilets are created equal when it comes to waste removal. You may ask yourself, well, how does one quantify if a toilet is going to handle an average or larger than average deposit? So enter MAP toilet testing, which is a third-party independent testing program that verifies the maximum performance of a given flush or fixture configuration. So since its development and release in 2003, MAP testing has been a major driving force in the improvement of toilet flush performance in North America. A toilet's MAP score represents the quantity of grams of solid waste that a particular toilet can flush and remove completely from the fixture in one flush. So the excrement is simulated using a soybean paste in a latex casing and toilet paper to verify performance. You can Google image the testing media, but it looks exactly as you'd think if you were to simulate the conditions. So essentially, the MAP test is a test to identify the failure point of a given configuration. According to the MAP website, when the program started in 2003, the average score across all tested toilets was approximately 336 grams of water, or 12 ounces. The initiative to have toilets be more efficient has driven those performance scores to an average of 882 grams or 31 ounces by 2017. So to keep all this in perspective, the average deposit would be in the 250 to 500 gram range. So this performance-based metric has also been adopted by Cal Green as a requirement for a toilet to be capable of handling a minimum of 350 grams per flush event. You may ask yourself why you have never heard of this testing or metric, but a metric you are more familiar with might be the EPA WaterSense label, in which the 350 gram performance requirement is the standard for. So you have seen it, but it's in disguise. So let's talk about urinals real quick. The installation of urinals is an important water conserving device compared to its toilet bowl counterpart. The green building standards set a half gallon per flush as the limit across the board, compared to the larger 1 gallon per flush urinals currently installed in most existing facilities. So the different types of urinal fixtures include either washout, siphon, blowout, or waterless urinals. The larger flow rates of about half a gallon to 1 gallon per flush will typically be the siphon type or the blowout that uses larger water stream to fill the bowl and P-trap, creating a siphon action via the P-trap, with the blowout being a more aggressive application necessary for high usage commercial applications such as stadiums. The lower flow urinals of about 0.125 to half a gallon per flush, are typically washout, which release a stream of water dispersed at the top of the urinal to wash away waste via dilution before leaving the trap. Although waterless urinals have come a long way since their inception, they are allowed by the corresponding green building ratings. They do present their own slew of issues while significantly reducing water consumption. Similar to toilets, ensuring the proper flushometer is selected for the proper corresponding fixture type is important in the selection process for new construction or any upgrades or renovations when it comes to urinals. Unfortunately, the drawbacks with any flushometer remain the same, with potential for non-calibrated and faulty devices, which can result in decreased efficiency and loss of water savings. Many of the urinal manufacturers offer a sleeker all-in-one model with the flushometer integrated into the porcelain housing, but this can lead to an increased cost because now you have to replace the whole fixture versus a couple components. So that could increase the difficulty of troubleshooting of potential issues. So let's talk a little bit more about waterless urinals, because obviously they save water, but what are some of the bigger concepts behind them and what should we consider? So we'd agree that the waterless urinals have their applications in place in the industry. It just may not be necessarily the best situation or application. So newer waterless urinal technology has helped increase the trap membrane to suppress odors encountered with the original waterless urinals, if you guys are familiar. But these systems still require an increased preventive maintenance and material cost as it relates to maintaining and replacing these membranes. So I'm sure those of us who have experienced the newer waterless urinals can probably attest that they do not completely remove the odor and would not necessarily want them installed in our facilities, especially if they have any significant preventive maintenance to our already stretched resources. So let's take a couple minutes and look into the different faucet types and that kind of thing, and how we can save water. So options for lavatory faucets are either manual handle faucets and automatic mixing faucets. So unless there's a specific use for this faucet, such as a laboratory or nutritional needs, it should be adequate to install either a half GPM faucet and or aerator, or retrofit the existing facility with compliant half GPM aerators. So the green building standards identify 1.2 or 1.5 GPM for residential and commercial faucets and private lavatory faucets. So think areas of your building that aren't for public, aren't available to the public or visitors. So more private settings in your commercial facilities. And then half GPM in public settings. And then quarter gallon per cycle for metering faucets, regardless of the flow rate. So looking for the EPA WaterSense label when selecting faucets will help ease the selection process in identifying fixtures meet more stricter performance standards. So some manufacturers had ventured to go as low as 0.4 GPM for their aerators. Currently, the CDC does warn the installation of any laminar flow restrictors and or aerators can promote the growth of Legionella. As a result, they recommend routine cleaning of these devices to be performed and necessary testing for Legionella bacteria to be conducted. So let's talk about hygiene when it comes to lavatory faucets. And I'm sure this is a very, very large topic when thinking about bathroom upgrades. So when picking an upgrade, not only do we want to focus on the reduced water flows through the efficient flush and flow fixtures, but we want to emphasize the hygiene in our selections. The CDC's recommendation, hand washing procedure prescribes a user to wet his/her hands, soap and lather for a minimum of 20 seconds, and then rinse thoroughly. Pretty sure we all know that. It's kind of ingrained in our brains. So automatic motion sensor faucets, although sometimes frustrating, help decrease water consumption with intermittent cycles, as well as reduce the spreading of germs by eliminating contact with contaminated water faucets. I know when I walk into a facility and I have to turn the handles, I cringe. I'm like, where's the automatic? I don't like touching faucet handles. So also to promote health and hygiene, there are new lavatory faucets that have an integrated timer where after you wet your hands to apply soap, the faucet will start a 20-second timer and the water will not turn on until the 20-second timer is complete. So this is a really great new strategy that ensures a proper time is spent while washing one's hands with soap. I have to admit, I did get caught. I think I was a couple seconds early and I didn't understand why the faucet wasn't turning on. And after, looking and seeing the timer count down, I was like, oh, shame on me. So it's really great if any of you guys have used those yet. So installing automatic soap dispensers can also help decrease unnecessary contact with germ-covered surfaces. It remains that proper use of soap and water continues to be the leading way to reduce germs in restrooms, with hand sanitizers containing at least 60% alcohol being used if soap is not an option. So just keeping that in mind. Okay. Air dryers versus paper towels. I'm sure this is a really big debate and conversation in many, many facilities for so many different reasons. So let's see what the differences are. So one argument you may have heard over the years pertains to which type of hand dryer, regardless of type and model, versus the paper towels, which is more hygienic, which is more effective, and which has the better environmental impact. So let's compare apples to apples here. It is estimated that paper towels cost 10 times as much compared to air dryers. So we're looking at $0.025 versus $0.002 per dry. But there's a secondary installation and maintenance cost of a fan dryer and required electrical components of the electric hand dryer that are not considered in this apples to apples. Paper towels also result in an unnecessary landfill waste and lead to an increased spread of germs. Without getting too much further into these numbers, it has been researched and documented that it is most important to emphasize the proper hand washing method identified by the CDC to reduce germ contamination. Although studies indicate air dryers increase the spread of germs via the airstream, this is negligible if hands are properly sanitized through the hand washing process. One caveat for these applications, though, is the use of air hand dryers in healthcare facilities where they are typically forbidden due to an increase in airborne pathogens compared to hand towels. And unless you are truly a fan of any given style of forced air type hand dryers, there does not appear to be a significant advantage as it relates to hygiene among any of the different styles of hand dryers. All right, so that kind of summarizes all the different fixtures that we wanted to go over today. And I did want to dive a little bit into water reuse systems, kind of in a bigger picture for you guys. Let's say you want to do a couple renovations and say you want to reuse water for your toilets, that kind of thing. Let's get a big idea of water reuse. I think it's important in many areas where there's a lot of drought. So let's dive in. So water reuse, also known as on-site wastewater treatment and reuse, or AKA decentralized wastewater treatment. looking at the different types of water. So gray water is untreated wastewater from domestic activities. So either from your lavatory sinks or from showering. And then black water is any water with a high BOD, so that's biochemical oxygen demand, and that's normally from your toilets or urinals. So you have those three kind of distinctions: clean water, gray water, that we're hopefully going to be reusing, and then black water that goes to the sanitary. So I wanted to talk a little bit about examples of systems that are capable of using the non-potable water. So let's say you have a facility that has a ton of gray water, it's non-potable. Now, where can you use it? Where can you reuse it? So irrigation is a really, really good system for this. Obviously, subsurface irrigation is required. No airborne or water streams above the surface are allowed. Toilet or urinal flushing is a great use for non-potable water. Vehicle washing, laundry, or dust control, just some ideas of where we can reuse the water. Some standards that we need to keep in mind when designing these systems is the NSF or ANSI 350 on-site residential and commercial reuse treatment systems. So these standards include requirements for, water tightness, noise levels for the system, where are the access ports for troubleshooting, how do we monitor the system and make sure it's safe at all times, where are the bypasses in case we need to include more water and we're not getting enough recycled. These standards have product literature and general performance evaluation to consider for your systems. So a couple things to consider when designing water reuse systems. So consider the use of recovered gray water. Where are you getting this water from? What contaminants are in that gray water that need to be reduced? So understanding where you're getting the water from, doing a test and seeing if there's anything that needs to be treated before you are reusing it in your facility. You need to understand the total volume requirements of the system. Let's say you're gonna be housing this water on site. How big of a tank do you need in order to have a system that's gonna recycle water continuously and not have any times where you'll need a backup water supply? And then also understanding the regulations when designing these systems. Also think of the length of storage that can lead to some bacterial growth and making sure that the water is cycled in a manner that recycles the water fast enough where you don't have bacterial growth, if that makes sense. So some typical components of water reuse systems, if you are thinking of, implementing these in any upgrades, what are some components that consist for the system? So a storage tank is a given. Where do you put it? That kind of thing. How big? Pipe fittings, valves. What kind of controls do you need for the system? And then what treatment technologies? Obviously understanding what the source of this water is and if any treatment is necessary, you'll have to get into the treatment technology side. And then hopefully not going too out of left field here, I did want to talk about a certain system that, can be considered in some bathroom facility upgrades that, are very restrictive in either space or type of system. So whether it's a healthcare facility where you can't put any plumbing under a slab, or in certain areas you're restricted. If it's a historical building where you also can't, you're very restricted in some of the upgrades. I did want to mention super quickly the idea of vacuum plumbing systems. So these systems are very awesome in reducing water usage. So this system uses a specific toilet. You can't use a traditional flush type toilet. So they use vacuum toilets that are as low as a ½ gallon per flush. So before, earlier in the presentation, we were looking at, 1.1, 1.28, 1.5 gallons per flush. Vacuum toilets are much, much more water efficient. They also take less piping in order to get the job done. The pipe sizes are smaller because you aren't dealing with gravity type piping. You don't need any vents. Obviously, it's going to the vacuum system. You need airtight seals, that kind of thing, but no vents through roofs. And then the piping also has minimal sloping because it has that force from the vacuum pump pulling everything through the system. So as I mentioned, it's a super flexible design. No underslab piping is needed. So I just wanted to mention this type of system if some of you guys are interested in plumbing upgrades or you didn't think it was possible. But yeah, I think that brings us to the Q&A session.
Right, well, thank you, Daniel and Carrie, for the great presentation today. We've been receiving some questions during the Q&A, and Daniel's been kind to answer them for us. But if you have some more, please type them into the Q&A at the bottom of the screen, and we'll ask some of our presenters here. We're going to switch over to the video, if possible. There we go. So Carrie or Daniel, you talked earlier in the presentation about the dual flush toilets and the problems with user error. Are there any best practices or any tips facilities can do to get people to understand how they should be using them better?
Yeah, what we've seen is, and it's instructions. I mean, it's there are some instructions where they it actually says on the actual fixture, what it's one for liquid, 2 for solid, signage in the bathroom. So really just educating the user on utilizing it. Same thing with kind of typically on the green handles, it'll say down for this, up for this. And it's just kind of just educating the users on how they should be utilizing and what they should be using in that process. So it may require a little additional signage or making sure you select a fixture that it's clearly identified on there. But that's typically the best practice in identifying that. And, putting on there, on top of that, this is a water efficient fixture, and identifying why it's a dual flush and kind of the consequence of it. That'll typically assist in that process. So
I'm also, not to dwell on this, I'm also not sure if we have any manufacturers on the line, but a lot of the times, like you mentioned, it's push down for dual flush and up for single flush. Admission here, I use my foot to flush, and a lot of times it's easier to just push down. So what about a system that, maybe the down flush is the single flush and the dual flush is up, or, a system that's more hygienic, that is more, I don't know, user-friendly. Is that bad to say? I probably shouldn't admit, but.
I think we're seeing more and more to those, and I haven't seen any studies on them, but it's those brass or anti-germicidal handles where at the same time it's kind of user experience. I don't know if that means that you're not going to put your foot on it, but now everyone knows it carries those foot germs. They're all over the handle, so don't touch the handles. But yeah, it's I guess that's kind of the negative side of the automatic flush faucets. So it's kind of you're damned if you do, you're damned if you don't, unfortunately, in the installation. So
that's why it's very important to wash your hands after anything in the restroom.
There you go.
Do you know of any, speaking of the dual flush, are they coming to a symbol standard among manufacturers, or have you heard if they're leaning that way so that it's just commonplace for people?
From a standardization point of view, I mean, I haven't heard anything, Carrie. Have you? I don't think that they're.
That's a really great idea, though.
Yeah. So, we've been seeing more of the just high efficiency, kind of those 1.28 flush toilets than the dual flush. They kind of had their time in the sun for a while, along with the waterless. But again, that kind of, or on the urinal side with the waterless urinals, not waterless toilets, that'd be a rough show. But a little bit of potty humor. But they definitely, kind of all depends on your existing facility. If you're just upgrading, if you're upgrading, do you have the right pipe size for it and the configuration? So, just putting I think Carrie mentioned it, but just putting a high efficiency fixture on your existing plumbing system may not mean that you have the proper pipe sizing and drain and vent and everything to accommodate that type. So,
If you're going to do the change out for a tank toilet to a dual flush, is there a bowl design that wouldn't be appropriate?
Yeah, so there are retrofit kits. We've seen some success in much smaller applications where it's just kind of an individual, or if you have an old existing toilet that you don't have the budget to do, but you still want to upgrade that flush fixture, where you can put in a fixture that either limits the water intake on the bowl side, but there is a proper seating, and again, just using the wrong bowl type with that flushometer will not help you in the long run. So,
One attendee wants to know if you could explain the blue dye test a little bit more.
Yeah, so in your water facility assessment, what you can do if you're not sure, I think we've all seen urinals or tank type toilets that have that kind of run. On the tank type toilet, you can put the blue dye in the actual toilet bowl in the tank top, or in the urinal, or in the toilet with a flushometer, you put the blue dye kind of around the edge, and you monitor it to see if there's leakage over a certain amount of time, or if it's kind of dripping down the side of the toilet. There should be no bypass in that fixture. Then you're having a leaky fixture or a leaky diaphragm closure on that flushometer. So you're able to use that just to visualize kind of how much water leakage. It's hard to quantify that actual consumption or actual water leakage, but just to identify, hey, I should probably reduce this compared to, okay, I have a tight fixture where there's no leakage on an unused fixture. So it's just that visual representation. I mean, you can think of, even using kind of the blue toilet bowl cleaner as kind of the same impact. If gravity is going to come to effect, but if there is leakage, it will disperse with kind of a V shape down the side of the fixture bowl. So,
can you talk more about the automatic motion sensors on faucets and how they're decreasing the water consumption? There's been studies out there that show that they actually increase it, probably because they go off at wrong times and things like that.
Yeah. So, one of the things that we've seen, and it's kind of a function of kind of green projects or LEED projects, is that you'll go in and you'll set that water system setting to its default setting, or you'll adjust it from its default setting to have a cycle of 6 seconds, under the assumption that, okay, well, if it's 6 seconds, that one cycle is enough to actually wash your hands. But by the time you get the thing on and to get the soap off the hands, you may be running that cycle 2, 3, 4 times to actually get that soap off your hands. So I know one of the things Carrie mentioned and we've talked about is recommending in kind of the current facility requirements or your owner's project requirements to set that cycle to 20 seconds to encourage, especially with everything going on right now, to set that to a 20-second cycle with the internal sensor setting, so that you're not constantly waving at it and losing that time in between. The sensor sensitivity can also sometimes be set, but a lot of times it's just it's not too much additional technology is going into these items. So making sure you have the right timing on it, so you can actually utilize it, and you're not just running through cycle after cycle of the thing running. Then you're in a better position. So.
Also, sorry, I do know that some of the sinks where you have an automatic soap dispenser right next to the faucet, sometimes you're just setting both of them off, just doing your regular hand washing. So I definitely recommend the soap dispensers that are automatic be out of the bowl, but I know that's, common practice nowadays, get all the mess in one spot, but maybe making sure that the sensors don't trigger each other. I know I use a lot more soap. It's just squirting out sometimes, and you just have to kind of cover the sensor. So just be careful in that sense too. Not sure if you guys have experienced that too.
As we have a new emphasis on healthy buildings and we're getting people back into the workplace, are there any, what would you say are the priorities that facility managers should do in regards to enhancing their plumbing fixtures or their plumbing systems? What should they tackle first?
Yeah, so, making sure that the quality of the water, especially for systems that have been sitting for a while, going through, potentially doing a flush, verifying, if you have a facility that's been completely unoccupied and you haven't been running water through those systems, you're going to want to go and verify that the traps are primed, they haven't dried out in the system from an odor perspective before you get people back in the facility. You want to make sure that you don't have any contaminants in the water. One of the comments had a question about Legionella. Unfortunately, with hot water systems kind of just sitting around, there is potentially the presence of Legionella. So I'm just going through and making sure you're cleaning out these facilities, you're checking the traps, and then you're running things as often as possible throughout the fixture, so you don't have these dead points that have the potential for bacterial growth, and also just rust and contaminants to collect in the system. So, prior to that reintroduction, kind of having an assessment, you may want to do that water assessment at that point. Maybe a good time when no one's in the facility to go around and check all the fixtures, flush everything, make sure nothing's stagnant, make sure there's no blockages in the system. Make sure everything's running kind of status quo, and hopefully you didn't go in and shut off all your water beforehand and everything's just been sitting there for that time being. So.
Water conservation is already a priority in some states, especially in California, Arizona. With the pandemic and this increase, emphasis on hand washing, that, we might see even more higher consumption. What are some best plumbing strategies to help manage consumption and demand?
Yeah, it's a tricky question. It's new technology. A lot of people are, especially with new design, a lot of people are very hesitant to use gray water systems. I know Carrie went into that a little bit, but if we could transition our systems to gray water for irrigation systems, that's basically what that is now. So rainwater roof recapture, it doesn't even have to be a high-tech application. Barrels of water capturing your roof runoff from your wells, can help to offset the consumption in your system, to that irrigation section, that, will again, just help to offset that. In the commercial industry, it is, or in commercial building, the numbers I have is that, the commercial water uses about 17% of the municipal water system. Of that, close to 10% is used on irrigation. So if we were able to get a large portion of that introduced with this gray water system, and or using native vegetated plants that match the inherent systems, or the inherent environment, to kind of reduce the need for them to have additional watering or additional measures to be taken place to kind of offset the lack of native vegetation that they have. They may not be as pretty, but it just kind of embracing that everyone's now, it seems like everyone's getting into gardening now. So make sure you're planting local plants. You're not going out and getting all these palm trees for New England, so strategies along with that. There are a lot of ways to do it. The aerators, installing aerators in your facilities, in your actual plumbing fixtures, which can disperse the water. You can lower your reduction rate depending on the manufacturer, to have the sense that you're using more water than you are, since it's, and some of it's even a mental thing, of people who are washing their hands over and over again because they don't feel that their hands are properly cleaned. Then education and making sure that our systems aren't leaking. I was involved in the National Research Defense Council, their initial retro commissioning or retro audit process in the identification. In that process, we were looking to ban the use of single pass systems. So usage of single pass water through ice systems and kind of old school hotels, motels. Also looking at your cooling towers for larger facilities as they're using processed water by, reducing the number of blowdown cycles that you have can have a large impact on your overall water consumption to help kind of save it piece by piece by just, not having that. I've seen horror stories where there's just a hose going into the tank or basin heater for a cooling tower, and that's your blowdown strategy. So we all have to do our part and identify our own measures. Your measure may not be the same as mine, but you're trying to identify what that is and do your best to improve that and fix the leaks at home. So.
Is it possible to retrofit existing plumbing systems to the vacuum plumbing system?
I believe if you have a case where the system is large enough to justify using an entire vacuum system, if you're changing out one bathroom, depending on the need, you might need to reconsider. But yeah, depending on the size and space that you have, I think it's a good option to incorporate a vacuum plumbing system.
Is it more beneficial to do it for a new install than a retrofit?
I think when you're going through the design process for a new installation, it's definitely easier working with the vacuum plumbing system because you can make sure all your bathrooms are connected to it, all your plumbing fixtures are connected to it. It's definitely just more work at the renovation stage, but depending on the application, it could be very beneficial for sure.
Going back to the touchless faucets and having them come on when you don't want them to, is there any emergency shutoffs for after hour use to make sure that it's not continually running or anything like that?
Specifically, I haven't seen anything with that. I mean, again, that's typically a user complaint if there is a faucet that's running continuously. There's so much that's not taken into account with water fixtures and plumbing. It's kind of I don't want to say the dumber of the utilities, but we monitor so much on building energy consumption. We really ignore a lot on the water energy consumption within buildings and the technologies and efficiencies. One way to kind of focus on this could be a sub-metering strategy, which would identify a constant leakage outside of normal operating hours. I haven't seen personally too many of those flow fixtures that fail open. If anything, they're going to fail close and not operate, but that doesn't help you if you have just a manual faucet or someone, if someone's found a way to bypass it, or, someone put one of those little birds that goes up and down right in front of it to offset it continually. So, but, in newer facilities, if you're able to sub-meter, bathrooms or residences or, anything with the meter that would allow you to identify that, as we get farther and farther down this, reduction in this natural resource, the things are only going to tighten and restrictions are going to increase that, are going to require additional water sub-metering so we know where all the water's going, and hopefully we can use that data to identify, potential leaks.
Any advantages for battery operated or versus the 24-volt sensors on fixtures? Is there a preference?
Maintenance, batteries you're going to have to replace throughout. But, on an existing facility, you typically will see, if they have to plug in, if there isn't a GFCI around there to plug it into, you'll typically see the battery operated ones. If you're doing a whole new renovation, you're able to limit the amount of battery change out and just maintenance on it by doing the plug-in. Obviously there probably is, some point of failure if you just have a plug sitting there and someone comes and pulls it out from the bottom of a sink. So each have their positives and negatives kind of for the application. I typically like to see the plug go kind of in behind the wall if you're able to have an outlet back there. So it's kind of tamper-proof to an extent versus that battery operation and, potential for corrosion and left alone. So that's my preference, but, it could really depend on the size of the facility. So you could have 1,000 bathrooms, you could have one big bathroom. So.
Any thoughts on using sphagnum moss as an alternative for chemical cleaning and cooling towers? Can that be used to control Legionella?
I haven't seen that, Carrie. Do you have any No.
No, unfamiliar.
Yeah, I'd like to look into that a little
Yeah.
bit. You know, we're seeing a lot more and more restrictions. You know, my market's New York City. More and more restrictions as people are getting sick from cooling towers walking by them, unfortunately, over the past couple of years. So new technology, people are very hesitant to introduce anything new due to potential litigation is what we've seen. So unless unless the claim can be backed up with, with science and kind of a guarantees, I'm not sure where that's going to go. So.
Do you see with COVID now that touchless restrooms, that's just going to be the norm, that you're just going to see everybody kind of retrofit fixtures or replace them? That the traditional, the touch fixtures are just going to be gone?
Yeah, for sure. I think everything will be automatic in the new bathroom.
Yeah, and it's dual functioning in both the hygienic side of it as well as the water saving side. I mean, I know we touched briefly on the failure of an automatic faucet, but it's a lot easier to leave the faucet on than it is for, that's a lot more common than seeing that failure point. So definitely see facilities going towards that for multiple reasons.
Mm-hmm.
On the cleaning side, are there any types of environmentally friendly cleaners that can be used for lime scaling or calcium buildup in the P-traps?
Yeah, there are green options out there. It's the different different items have different impacts. You kind of have to look into them individually. There's just green cleaning solutions. I have a list of them that I don't have handy on me right now, but I could send over to you for kind of again, LEED and USGBC are some of the leading, along with the wellness, just to make sure the well certification, to make sure that there's no nasty contaminants or California Act contaminants 56 or 52. Sorry, I'm not from Cali. So, but those contaminants can have negative impacts, where those industries work closely to try and do their best to make sure that we don't have that. There are no known harmful contaminants in there, but it's so many things pop up on each day. We're seeing now more and more that you shouldn't be putting hand sanitizer unless you're 100% sure what's in there, and that's kind of going back and forth. So it's kind of, again, a damned if you do, a damned if you don't scenario. So.
Mm-hmm.
We have time for one more question here. Can you speak more on the temporary metering of systems to obtain baseline usage? And specifically, they're wondering if there's a cost savings to doing this with existing buildings that only have 1 meter.
Yeah, so your temporary metering, you can either we personally use ultrasonic flow meters, so a strap-on style meter. We have a General Electric one, which is a pretty fancy device to measure actual water consumption, which is a temporary meter. There are other ultrasonic strap-on meters that will verify the flow of the water and trend it over a given amount of time to identify your water consumption. There are expensive meters, there are cheaper meters. If you have a large enough facility or portfolio facility, I always recommend, FMs to have a good stock of testing equipment to be able to identify these measures. So, via that strap-on meter, and or if you have, a balancing valve in the system, taking the pressure differential across that valve and verifying that, just like you would a testing and balancing report, is beneficial. If you just have that incoming meter, I guess you could, you'd have to learn how to read it, but that temporary monitoring, there's a lot of great technology out there and companies that are, making new software applications that tie into these meters to kind of get that temporary data. So, but yeah, but I've seen those meters for as low as 400 to 500. They may not have the same accuracy, but again, if you're comparing them to a baseline, you should be able to get some good data out of there.
Well, we're right up on the hour. I wanted to thank Daniel and Carrie for taking the time for this great presentation today. Thanks to all of you for attending, and to our sponsor, Chicago Faucets. You will receive an email with a link to today's presentation, as well as a link to an examination for a CEU certificate. If you have any questions, feel free. Daniel and Carrie are receiving a copy of all the questions today in case we didn't get to yours. but look for more webcasts on facilitiesnet.com, and thanks again for attending.
Thank you.
Thank you.